Hi everyone, more strategies today. Hey, hopefully this will make ionic bonding a little bit easier for you, kind of like we did covalent yesterday. Let's start with aluminum and fluorine. Since aluminum is a metal, that's going to be an ionic bond. Since aluminum is in column 3, it has a +3 charge and 3 valence electrons. Let's look on the periodic table. So aluminum is going to have 3 valence electrons, and it's not too far of a stretch to say that it's going to lose those 3 electrons, not gain those electrons. So it'll eventually have a +3 charge when it's an ion. Fluorine has 7 valence electrons. So I just did the Lewis dot structures for those things. And if you'll notice, aluminum doesn't have enough to share. It's going to want to lose those 3 electrons, so it's going to start transferring those electrons. So fluorine needs 1, so one of those electrons can go to fluorine. Fluorine's all done, so we're going to have to add more fluorine in order for aluminum to get a full valence electron shell underneath, which is going to look like 0 when we take them all off, but really underneath it's a full 8 valence electron shell. So aluminum is going to transfer those extra 2 electrons, each to 1 fluorine. Then aluminum's all good underneath, all the fluorines are good, and we're done. Therefore, the formula is going to be aluminum. We only had 1 of those, so you don't need to put a subscript of 1, and 3 fluorine. Remember that subscript, the one that kind of goes lower and to the right, that tells you how many atoms of that element that you have. Hopefully you were able to finish up the questions, all of the questions. The ion charge for aluminum, it's 3+. There's only 1. So the total positive charge we have is 3+. Fluorine, on the other hand, has a 1- charge when it's an ion. Remember, it gains that 1 electron. How many are there? There's 3. So the total charge from the fluorine atoms is a 3-. Hopefully you noticed really quickly that that 3+ and that 3- are very similar.
KO.
You notice that one was a plus, one was a minus, but they're both a 3. So they are the same but opposite charge. What you're going to find with ionic compounds is that our positive and our minus have to equal. Otherwise, we're going to have a charged particle, and it's just going to keep on bumping around in the world until it does find something to bond with, until it becomes kind of neutralized. Go ahead, summarize that bottom. Hopefully that helped you. Pretty easy stuff. The positive just has to equal the minus side. Okay, the positive side always shows up on the left. The negative side shows up on the right. Have fun.